called the Mars Reconnaissance Orbiter, or MRO. Now, this spacecraft will use advanced science instruments and high-resolution cameras to scout locations of interest and possible landing sites for these human missions. To help us understand how the Mars Reconnaissance Orbiter will work, I spoke with Scott Streepy here at the NASA Langley Research Center to find out more.
Well, the Mars Reconnaissance Orbiter is a multi-purpose spacecraft that's designed and built for the next NASA mission to Mars. Basically, the orbiter will continue NASA's exploration theme of follow the water. It will be in a very small science orbit and will be looking for water ice, vapor, and liquid water on the surface, in the atmosphere, and even below the surface. Also, it'll be able to take some of the highest resolution pictures ever taken of Mars, and from that, NASA scientists can evaluate potential landing sites for future robotic and human missions. Also, after the primary science mission is completed, it will become a communication relay for future Mars missions.
So how is the MRO mission different from other missions to Mars?
Well, this particular mission has a high-resolution camera on board. It will take more detailed pictures than we've ever been able to take before.
Carrying the most powerful telescopic camera ever flown to another planet, the Mars Reconnaissance Orbiter will be able to show surface features on Mars as small as a kitchen table. This high-resolution camera will provide a wealth of information about possible landing sites by photographing the Martian surface in unprecedented detail. Now, how is this high-resolution camera different from other cameras used on other missions?
Well, this will be able to show things on a much smaller scale than we've ever been able to get on Mars. You can get details of boulders and surface features that we've not been able to take with pictures. For example, they'll lead me investigations to try to go and find the Mars rovers that are currently there, and maybe even look for some of the spacecraft that we lost previously to see if we can better understand why those didn't complete successfully.
Because the camera and 5 other science instruments will produce huge amounts of data every day, the MRO has been designed to send information at 10 times the rate of any previous Mars mission. An added benefit to the MRO is that it will continue to be used as a communications platform for robotic missions of the future, long after its initial 24-month science phase is complete.
It also has a new suite of instruments that we've never brought, except for some instruments that will continue to look at the weather patterns of Mars to understand how the weather impacts the motion of the water on the surface and in the atmosphere.
Now, Scott, what is your role in the Mars Reconnaissance Orbiter mission?
Well, I lead a team of NASA engineers that supports the Jet Propulsion Laboratory's navigation team during the aerobraking phase. Here at NASA Langley, we have unique capabilities in aerodynamics, aerothermodynamics, thermal analysis, and flight mechanics. We're bringing all that in to help the Mars Reconnaissance Orbiter mission during that critical aerobraking phase.
Aerobraking sounds like aeronautics and braking. I'm assuming this has something to do with slowing the vehicle down?
Aerobraking is a technique that you can reduce the size of a spacecraft's orbit without using very much fuel. And in fact, the Mars Reconnaissance Orbiter, when it arrives at Mars, will use its engines to put itself into a fairly large elliptical orbit. Instead of using additional fuel to make that a smaller orbit, what it will do is skim the upper atmosphere of Mars over a period of 6 months. And every time it goes through the atmosphere, it'll lose some of its orbital energy through atmospheric drag. But you have to be careful, because if you go too deep in the atmosphere, you could cause major components to overheat and thus damage them. By using aerobraking at Mars, MRO is able to save hundreds of pounds of fuel. And what that means is we don't have to send all that weight from Earth to Mars, and we can use maybe a smaller rocket or use that weight for something else like the science instruments.
So, Scott, what is the expected length of this mission?
Well, after aerobraking finishes, the primary science mission lasts 1 Martian year, which is about 24 Earth months. After that's completed, that's when it will become a communication relay for future missions.
Now, the term reconnaissance means that you're looking for something. You said you're looking for water. What else are you searching for?
It'll help the NASA scientists investigate future potential landing sites for other robotic missions, but also for the human missions that are coming.
So, Scott, finally, what are your overall expectations for the MRO mission?
I'm really excited about the MRO mission. Not only do you have subsurface radar, very high resolution images, the search for water in all 3 forms, looking at the weather patterns, and the ability to send detailed information to and from future landers. I think MRO is uniquely positioned to be able to not only expand our knowledge of Mars, but also continue our recent success at Mars.
The Mars Reconnaissance Orbiter is scheduled to take about 7 months to reach Mars and an additional 21 months to take its measurements. But researchers believe that it will continue to be a valuable communications platform for many years to come. Coming up, we'll find out about a new device that may give doctors a form of X-ray vision. But first, Did you know that one big concern for future human missions to Mars is the Martian dust? Because Mars has a very thin atmosphere and has about 1/3 the gravity of Earth, the dust on Mars reacts differently to wind than the dust here on our home planet. The smallest dust grains on Mars are as fine as cigarette smoke and can simply hang in the air, potentially causing breathing problems for astronauts if it gets introduced into the spacecraft. This dust can also form into tornado-like dust devils that can reach as high as 5 miles, producing huge storms that can engulf the entire planet. NASA is known for its breakthrough technology in aeronautics and space, but few people realize how important NASA research has been in advancing medical technologies. Although this research rarely specifically attempts to develop these technologies, many of its discoveries are spun off and